Now, uh, our next session is uh, 1 minute. Next session is with us. It is Dr. Ajbun Aram from New Current. He is currently in Chicago, USA. He is working in New Current company, an industry person. So before joining, let's join him and then we'll start the session 4 of this 6 days online faculty development program about Dr. Aram is Dr. Najmun Aram is coming. He is going to join our session from direct from Chicago, USA. Let's wait for 1 or 2 minutes. Audio. Am I audible clearly now?
Yes, sir. You are now
Yes, sir.
audible. It's a clear.
Okay, okay. I have communicated with Dr. Najmun Alam. He is coming soon. Uh, let's wait for him.
Good morning. Can you hear me? No. Good evening. Can you hear me? Okay. I have not. Dr. Palita, I think you are in mute. Oh, you cannot hear me. Okay. Okay. Just give me a second.
Okay. Am I audible now?
Yeah.
Is it okay, sir? Am I audible now?
Speaker. Okay. Speaker.
And now audible clearly.
Okay. Dr. Anam, am I audible to you?
Hello, can you hear me?
Yes, sir. I can hear you.
Yes,
No.
sir, clear.
If it is not working, access you could not access. Okay, give me a second. I'll change something. Let me.
Okay, sir. Please go. Okay, let me introduce Dr. Alam. Okay. Oh, okay. Is it clearly audible to Dr. Alam, sir? Dr. Alam, are you there? Dr. Najmul Alam? Dr. Najmul Alam, you are muted from your side. Please check. Your mic is muted from your side. Dr. Alam, you are muted. Please check. Please unmute. Please unmute your audio, sir. Okay, sir. Sir, you are muted from your side. Dr. Alam, am I audible to you? You are muted from your side, sir.
Can you hear me now?
Yes, sir.
Oh.
I can hear you now.
Okay.
Okay, let's start the session, sir. Can I start? So today there is it is honor to introduce Dr. Mohammad Najmul Alam, who is the principal magnetics engineer at New Current, a leading Chicago-based wireless power setup, where he has spent past decade driving innovation and contribution to a tenfold increase in company's growth. He holds more than 50 grants, US patents, and over 20 pending applications in wireless power technologies. Previously, Dr. Alam worked as a BlackBerry USA and Grameenphone Bangladesh for short period of time. Dr. Alam earned his BSc and MSc degrees in electrical engineering from Bangladesh University of Engineering and Technology, BUET, Dhaka. He spent 6 years as pursuing PhD and postdoctoral research at the University of South Carolina, USA. Am I audible to everyone?
Yes, sir.
Okay.
Yes, sir.
It's a clear.
Okay. Uh, Before joining New Current, he spent 8 years in academia, 2 years as a faculty member at United International University, UIU Dhaka. Now, his research on the design and application of wireless power sensors were fully funded by National Science Foundation NSF and the Office of Naval Research ONR, resulting in 12 publications in top journals and conferences, as well as additional $2 million in funding for the US Department of Energy DOE to the university. His expertise spans wireless power transfer, reconfigurable antennas, and wireless sensors. Outside the work, he enjoys cricket, tennis, and traveling with his family. Today, we are privileged to have him share his expertise on wireless power transfer in advanced communication systems. So, I'd like to request Dr. Najmul Alam to start his discuss his topic and enlighten us about wireless power transfer. Please, sir, it is over you, sir.
Thank you, Dr. Pradipta. Can you hear me okay?
Yes, sir. I can hear you.
Okay. Unfortunately, I know like my camera is not working. I'm sorry for that. I hope it will work miraculously without the talk, but it's not. Okay. So I'm very excited to talk in front of all you guys. Welcome to my talk. Actually, I want to say good evening. So it's early morning here. So before my talk, I want to say thank you to Program Chair, Dr. Shaldindo Panda. I want to thank Chief Guest, Dr. Neeraj Saxena. And also I want to give like a special thank to Dr. Pradipta because of all hardworking and arranging all these things. Before I start our talk, I want to say like a little story. I'm saying, this is very relevant to me. About like 18 years ago, I went to Calcutta to present my paper I think that was like 150 anniversary of University of Calcutta Radio and Physics and Electronics Department. That was a very nice memory for me. We spent 5 days over there, try, food and all those things, So uh, I want to remember that memory now. So, um, yeah. Let me present my thing, present my paper. Let me see. If I have any problem, just let me know.
Sir, is it possible to share your paper? Okay, sir. Thank you, sir. It is visible now.
Okay. Let me do. Okay. Can you see it?
Yes, sir. It is visible.
Okay. The goal
Sir,
of my
can you make it 1 minute, sir? Can you make it full screen?
Can you see it as a full screen now?
Yes, sir. Okay, sir. Go on, sir.
Okay. So the goal of my presentation is, of course, this is a short presentation and this is a vast topic. So I want to tell you the story of the wireless power transfer. So one thing is probably right now today, probably you are probably using probably one device. Maybe your phone is kind of wirelessly charged, and maybe your watch. But I think like okay, the technology started, I would say, probably around the 2007-ish. So almost like how much? 18 years. But it's expanding rapidly. It's expanding rapidly. So right now, probably billions of devices of wireless power transfer technology. And right now, probably everybody is using probably at least one device. But I'm telling you, like probably within 3-4 years, you probably use not one device. You're probably going to use the 3-4 devices. So that's the story I want to tell you. I'm probably not going too deep on the theory, but I want to like excited you about that technology and if it is helpful for your study, is helpful for your research. So you can go deeper and and I hopefully you'll get some excitement. So this is my outline of my talk. So I want to start with what is the wireless power transfer and the necessity of the wireless power transfer type of wireless power transfer existed. Then obviously we can divide it to near field techniques and the far field techniques. Current and future application, and then I'll touch base on what's going on the AI and how the AI is reshaping the wireless power transfer. People know Tesla. Obviously, Tesla is a car brand, but but again, the Tesla. I'm talking with the Nikola Tesla, the great scientist. Actually, he did his experiment on how to transfer power over the air. It's hard to tell what kind of experiment he did, but he definitely built a Tesla tower, and he tried to energize the other device far away from the Tesla tower. So the wireless power is transferred through the air. So, and that technology kind of revived by the MIT for different reasons. I'm coming to the reason of why people think that. Obviously, NASA research on the how to transfer power to powering their satellites in the space. So that is the concept they're always trying. And probably from 2020, 2010, now we see the commercial adoption. So I want to say why we need a wireless power transfer. So one thing in the technology world, like, necessity is the mother of all the invention. So if there's a necessity and then the technology coming, there's a necessity there, or there's a things that make your life easy. So that's why, like, the technology evolved and the technology come to the world. So one thing I always want to tell the people, or the part I understand, like how we are doing research and we are doing work, we should think about how that technology actually can change our life or make our life easy, or maybe save our time, right? So, okay, how the wireless power technology is important and why it's going to billions of devices. So obviously, you don't need to carry the cables and connector, right? And the device can charge automatically when you place it near a transmitter. And there is, of course, a safety issue. Like, so if the kids or somebody can kind of expose to the exposed conductor, and I'll especially have a slide on how it changes the working on the medical implant. And obviously for medical implant, and you don't have to sterilize thing. Or other thing is, if it's a medical implant, like if somebody has some kind of device or sensor inside their body, you need to change the battery like every few years, right? So that's a very costly process. That's the risk process. So, wireless charging can solve that problem. So, and the other thing is mobility. So obviously now EV is going everywhere. EV is going to going everywhere. So one of the thing is, like, you can charge your EV car when it's in motion, and you can actually go to a charging station, and then you don't need to plug anything. Right now there is a plugging device. Obviously there are challenges over there. So, and also there are new applications. There's new applications now. There are a lot of drones and other cases, like, the wireless power is very helpful, and I have seen that a lot of companies are working on that. One other thing I'll also tell you, I'll present that which company is working on what. It is kind of helping you to, if you want to really do the research, deep dive research on this thing. And so, okay. Wireless power transfer. So the concept is you are transferring the power from place A to place B, right? So it is a little different than in communication, because the communication, the goal is maximum power transfer, right? We don't care about the efficiency, but in wireless power transfer, of course, some cases I'm saying that we care about the efficiency, especially for near field. We really care about the efficiency. So, and when it's coming about the efficiency for communication, we don't worry about the, or maybe you can lesser worried about the temperature. Of course, maybe when it's transmitting, we are worried about the temperature, but in wireless power transfer, we always carry up the temperature, like, what is the maximum temperature device can handle, or what is the comfortable for a person. So we always worry about that. And then there's also emission restriction. I'll probably touch a little bit based on that. So there are, we call two different techniques. One is called near field technique. The near field technique is there is a coupling happen between through the induction. So basically, if there is a structure or a coil that emit the magnetic field, and in near field, the magnetic field coupled to another coil, um, and then the power transfer happening through the coupling. So that's we call inductive coupling or resonant coupling. So normally the smartphone, toothbrush, and wearable, they are doing the inductive coupling more. There is a resonant and coupling, and we are doing the resonant coupling for larger distance or a smaller device dimension. Normally the inductive coupling, the frequency we're using sub megahertz, like less than a megahertz. For resonant in case we are using in higher megahertz, like high frequency, like 6.78 megahertz or 13.56, or maybe between 40. There are also some capacitive coupling. So that's not popular yet, but there are some companies, and there are some applications they're trying to use capacitive coupling. So and there are I call it far field technique. So so that's actually transferring power through RF or microwave frequency range, or it can be laser, or it can be like optical power transfer. I mean, the concept of the microwave wireless power transfer is you have probably a high gain antenna, and you transfer power. Maybe not one antenna, one transmit antenna. Maybe you have an array of antenna, and you transfer power to the receiver. So in communication, obviously the goal is not transferring the power. So the communication and it can be very low power, but here the directivity is very important. Like, so you have to be you have to use very directive antenna to transfer power, and probably not only one antenna, you can create a beamform and transfer the power to point A to point B. So there are some companies working on that. I'll tell you what they try to do and what the application look like. Then there is a laser optical power transfer. Obviously, the satellite or the drone and the remote sensor, they're trying to do that. Or the idea is you probably can have a solar cell in the space, and you can and have that energy transfer to a smaller device. So that's kind of a concept is there. Okay, so I'm talking about the near field wireless power transfer. So this is very short range, and now we call charging technique. So there are a few companies that the PowerMat. There is a Pioneer, but now PowerMat is I think the merge with Vitrocity. Vitrocity actually is a big company. We probably see there are we call a lot of, and they're a technology of the EV charging. In the Vitrocity probably have thousands of patents. The new current is so I've been working with the new current for 10 years. New current is working a solution for different wearable, smartphone, and medical. I can show you our product, how many product we actually worked on, and right now they have the wireless power solution. So we are also a technology company, and we also design and license that. So you probably know the Mophie or the Energizer. They are kind of building the wireless charger and space everywhere. And there is some company, they are doing using the application like phones and wearables like Apple, Samsung, Huawei. So they're the big players in the market. So because of them, the technology actually is spread, right? So there's a resonant inductive coupling. I'll tell you about the difference. What is we define the inductive coupling versus resonant inductive coupling. So there are a few names, and there are two. The OSA is one of the company. They're going to work on the resonant and RF hybrid solution. There is a few company I mentioned, very less common, but they are also in the space, the capacitive coupling. I'm hearing a noise. I mean, Dr. Prince, are you there?
There is a small noise is coming.
Okay.
I think please all mute your side. Please, whose mics are on, please mute it.
Okay.
Okay, go on, sir. Go on.
Okay.
Please, somebody in the road, please mute your audio. Please. Please, somebody on the way, please mute your audio.
Okay.
Okay. Please mute your audio. Okay, sir, go on, please.
Okay.
Please go on.
Thank you. Thank you so much.
Continue, sir. Please continue, sir. Please continue, sir.
Okay. Can you hear me now?
Yes, yeah. You are audible.
Okay. Okay. So, okay. So how the power transmission happens? So you have your transmitter circuit, right? And obviously that transmitter circuit, and you have your amplifier over there. I mean, of course, you can have several different ways. You can probably have a DC-DC converter, or you can have the like other kind of amplifier. One of the popular amplifier is right now for resonant is starting for Class E amplifier. So your amplifier is efficient. So you actually from the DC, you actually converting your signal to, if it's inductive coupling, you have to have a signal of 100 kilohertz kilohertz voltage or current. I'm saying that, of course, the current. So you have to, so that current flow through the TX coil, and then it creates the magnetic field. The magnetic field coupled to the receiver coil, and the receiver coil, and then you have some matching circuit there, and then you have to rectify that if you need a voltage regulator or voltage doubler, some kind of circuit to actually have that, and then you can get your output. So one of the way of the difference between we see the resonance coupling versus so resonance coupling is normally as I said before, not really sub kilohertz, normally 13.56 megahertz, or some megahertz. So uh, why there is a difference? So normally for resonance coupling, in the power transfer is controlled through the VPA. So the VPA means the amplifier input voltage. So that's the one way you can control that. And for inductive coupling, there is a duty cycle, so you can change the duty cycle, and you can change the transfer power. Or you can sometimes, what we do is, they are not fully close to the resonance, and they have a curve, and then that curve has a different efficiency and power limit. So you change the frequency to get that voltage. So or you can control the duty cycle. There are different ways to do that. Here is some standard. So you're probably familiar with now the phones, and the phone actually have a WPC wireless power consortium, like we called it a CHI standard there, and that's for mostly for the phones and wearables. And so there are like up to like 30 watt. There is also right now the Apple is bringing the MagSafe for Apple own ecosystem. So obviously Apple is a big player, so that's why everybody have to follow Apple. So and then now the WPC is coming with the Apple standard, which they call Qi2. So which actually have magnets, and for that power range is 15 watt to 30 watt. There are old airfoil standard that you can use 6.78 megahertz. I think the recently most interesting thing is we called it NFC charging. That's actually because this is like the working with the NXP, because already there is this NFC standard there. So NFC standard, you probably use NFC payment process or NFC communication, right? So now what they're doing, the same NFC chip can be used for the both. So if what I'm going to say is, previously your phone has the NFC chip that's actually working only for the communication or the payment or like some kind of data transfer. But now the chip now they are making, they not only can do that, they can also do the NFC charging. So that's why that's pretty interesting. So this is a very important technology for like a smaller devices, like like earbuds, wearables, especially like a smart glass, stylus, like so all those technologies. So there are some 6.78 airfoil resonance system for tablet, laptops, maybe for drones too. So, and that's also interesting that you can charge multiple devices. They're standard. So and then you can actually have your own space for designing, because ISM band is open for that. So okay, this is like a historical timeline for wireless charging of the phone, because I think that probably now every phone has some kind of wireless charging. So I think the first probably phone was like in 2009, the Palm. So, and they have the wireless charging. So I think the major breakthrough comes like, I think 2016 in the Galaxy S7 wireless charging becomes a mainstream from the Android flagship. So obviously, Apple is not the early technology adapter, so Apple takes time to do that. And now, every phone has wireless charging. So obviously, from 2020, Apple introduced the MagSafe, the magnetic aligned Qi charging. So and so one of the problems, is for the, I'll talk about it a little bit later. I'll touch on this thing, is the wireless charging. One of the big challenge is alignment. Theoretically, you can have a large charging pad and you can charge it anywhere. But the problem is, if you do that, saying, okay, like I have a large charging pad, and then I can charge my phone anywhere, that is possible. But one of the problems is then the magnetic field coupled to the other part of the devices, as like a screen and probably PCB board and the IC, and then actually that create a EMI problem, or for them also is hitting up the other part of the phone. So that's the one of the biggest challenge in the Qi. So the Apple MagSafe is kind of solving that with the alignment, with the magnetic alignment. And also, there is always like working on, and can you transfer the higher power so that we can charge faster. There is always a need for the fast wireless charging. So you probably see that if you have a USB, you're probably charging faster than probably have a wireless charging. So in some point of time, probably you can have that. So I'm a little bit talking about the far field wireless power. The picture misleading, I would say, on the right side. That's much more applicable for the laser. But there's a company like the OCI and Energis, they want, and not that, they want like a centimeter, like, maybe 10 centimeter wireless charging. So the idea is, in a room, they have their transmitters sitting probably on the table like a tower, and you can put all your device on the side, and then all the device getting charged. And this is helpful for some of the consumer electronics, or maybe some of the, like a store, like say, okay, I have an electronics store and I have a lot of electronic tag, or I do have a lot of devices that I need to charge like frequently. So that's they are trying to solve with that. So, but one of the problem is that if you guys familiar with the communication, there's a phase transmission formula. There's a loss of the loss on the path. So that path loss is real. So there is no way they can reduce the loss in that path. So basically, if you go 10 centimeter, there is probably huge amount of loss happening as a path loss. So the efficiency, and I measure it sometimes like a 1%. That's one of the biggest challenges with that, because obviously, then you are going larger distance, right? So if the application needs a larger distance, like, especially for the sensor network or or some consumer electronics, you can actually have that. So laser, as I say, the laser is always a space thing. So a spacecraft or the space station, they are always trying to do that. Probably they are try to do it for probably some drone charging or something, So this is really high power, and they don't have a restriction on that. One other problem with that, we call it FCC certification, because one of the thing is that this RF energy is not good for human body. So then they have a limit, international limit or IEEE limit or European Union limit on that. So for far field, if you want to transfer more power, they have a like a 1.6 watt per kg a, a limit. So that is also a challenging for some of the RF microwave power transfer. So that's if there is a case where is a like empty warehouse or something, there is a no human traffic, then you can actually use some of the RF technology. So okay, okay, I have a presentation. Okay, so the RF, the same concept. Then you have a DC source, and then you have an RF amplifier, and then amplify the signal, amplify the signal to from DC to the frequency. Right, probably 900 megahertz for like I know that OCI is using. Okay, there is a frequency band. Okay, then you can transfer that, or you can use the ISM band. So ISM band is an unrestricted band. This is like industrial, scientific, and medical. So the normally people are used 2.45 gigahertz ISM band, or 5.8, or maybe 28 gigahertz ISM band. So and for far field wireless power transfer, always if you have to use the antenna, so that needs to be very directional. So you have to use the horn phased array or some parabolic dishes for these are very special cases actually. So these are not general. So okay, here is one example that I was talking about. This proto was built by the OSIA. They called it Kota Techno wireless power transmitter. So there is a tower you see, and then you see that it's plugged in, and then they are having a little battery they want to charge, so on the side. So um, um, so the actually in the tower have a lot of small antenna, like creating a probably 64 antenna array, and then it's find a receiver, and then it's directed the beam towards that receiver. So this would for, as I say, the remote location or inaccessible location. Yeah. Okay. I'm really excited about to talk about the wireless power technology like new current journey. So these are some of our product right now, and luckily I work all on this thing. I give you some glimpse so that you can have a little bit more idea of what's going on right now and what's going on in the future. So 2 months ago, we launched you see the top left corner, the Nuance Audio. This is actually a glass. This glass is for supporting the two things. Like it not only supports if you have obviously we're wearing glass because you have a vision problem, right? But this glass also have a hearing aid, and so basically if you have a hearing problem, you can wear the glass. So there is no like earbud or something. You can wear the glass, and then glass kind of there's a small speaker back of the temple of the glass, and kind of amplify that. So that's the Nuance Audio from Luxottica. The Luxottica is the brand, like the owner of all the biggest brand, like Ray-Ban, and you can name those things. Okay, why we come in? So the thing is, one of the problem with this kind of a smart glass is how you're going to charge this thing. And then if you want to charge it like a small USB-C or USB thing, it's very inconvenient. So we design a charging pad. Also, we design like a charging case too. It's now we're working on that. So you place your glass and you place on the charging pad, and it will get charged. So instead of you need to find the plugs and you have to plug in. So that's the benefit of wireless charging giving that. And then okay, we are doing it for using the resonance link or like 30.56 megahertz. The P-Core, this is another interesting project we are doing. So because actually they have like a treadmill and other equipment for the gym. So so the gym actually have like a tag. So so they have a pad that you can drop in your phone, and you actually have a flexibility, like and it will get charged. And also because there's an NFC tag with that device that's actually it's designed. So so not only that, it will tag your membership reading from the NFC card reader, like NFC system from your phone. The then there is a called Poly or HP. Now it's HP bought the Poly. So they have like a whole headset, like you need to charge the headset with USB-C. There is a stand, you can actually charge it on top of it. On the base, actually you can charge your phone too. So and then there's a bunch of earbud, you understand. The pop socket is a very interesting project we did because a lot of people, it's super popular. Then you can have like a pop socket. The other problem is if you have a pop socket, then normally the charges distance between the TX and RX is like only 2 to 3 millimeter, maybe 5 millimeter. Now because of the pop socket, or if I have a thicker housing or something, that now your charging distance go up 3 times more. For Qi, it's a very hard problem to solve, in the sense that the Qi or the coupling system, it's a closely coupled system, so you have a very close couple. So we just come up with a design that can charge up to like 15 watt of power. So that's the first of its kind to do that. Hoop is a very interesting project we did. The Hoop is a project that's track your activity. If you are like the golf, you probably see that you can have their watching that they have the putting this device. So the device they are using, the Hoop, the fitness band, they call it. The fitness band, they wear it for like 30 days. So they continuously monitor your heartbeat. It always continuously monitor your sleep pattern. So, and it gives you the pattern and problem like in your thing. So on the thing that they're using this thing so that the trainer can monitor his status, like, does he get a very good sleep like the night before or something like that. So one of the problems they faced was there's a previous the previous generation was like a connector-based charging system. So, and that's why that failed, the connector. And then one of the problem with if you have a connector, you cannot make it like IP67, like a airtight, or the or water or air kind of creating the problem. So that's why we bring in the wireless charging for them. So that's why you just wireless charge that you need. So that's kind of helping them. Honeywell or Zebra, these are the barcode scanner. You probably see that your UPS driver, like your Amazon driver, are using every day. So one of the problems they face is they have a charging problem. So right now we designed the stand for them. So they just place this thing on their truck, like, and then it's getting automatically charged. So then one interesting thing is I can probably last you like getting a little bit. So the prevent biometric is it's called concoction sensor. Basically, you probably see that when the boxer have something in their mouth, right, or that maybe the player playing the ice hockey or something, like placing this thing mouth, that actually if you fell, and then the concoction sensor give you this signal that okay, he's in trouble, or like so that's the concussion sensor. A lot of now using, so that wireless charging is kind of helping them make it airtight. So there are a lot of physical sensors coming probably in. You probably see that you have body movement and all other things. So sponding is a very interesting thing. This is a basketball charging. So you see probably that's the very interesting thing for AI and other thing, because I see a lot of people now have the cricket or the football, like, and the basketball. They want to train themselves, like saying, okay, if you're balling, like how your ball swings, like 20-30 degree, right? You need that live stream data. So it's like some point, like, you are watching IPL and see that Bumrah is bowling and his ball swing like 20 degree or 30 degree, like, you can saw all those statistics. So one of the thing, that's the thing they are using for the basketball, and they're also doing this thing so that they can train people, like, what should be the power on the bouncing and the pattern. And one of the interesting thing we did for the Spalding in the basketball is wireless charging the basketball. That's a very interesting application. And I want to touch a little bit on the IP. So and how so right now, in our journey, we are holding the 400 plus patents granted. So this is one of the patents we are working on. So that this is a concept of the repeater. So you probably see I can go a little bit. So you see probably the OCR solution, but OCR solution using like antenna. But here we try to build a solution not using the like a gigahertz antenna. We try to solve the problem at like 6.7 or 30.56 megahertz resonant link. The idea is you have one main transmitter antenna, and you have bunch of repeater position at different location, like, one position there are 90-degree position, so that on the right your phone or your watch can charge it. So this is kind of the thing we work on. So the one of the thing is, when you're developing the technology, the consumer or the companies coming to us to solve their problem, or we go to them like, okay, we have a solution for your problem. So and then we try to develop those technology and implement that. So this is like one pattern I'm just mentioning. And this pattern, obviously, you see that for me, I have to do a lot of magnetic sim, like how the field of a transmitter antenna is shifted, how can change the field or couple to the field to the, we call it repeater antenna, the other antenna. And if we do that, if there is a peripheral device like a watch or the phone, like, so how they are going to connect it, and, how much power transfer can be possible, and how far you can place your device from that, say, wireless charging tower. So this is one of the work I'm just mentioning. So you probably see a lot of our works. So that our goal is, we want to be leader. Obviously, we are one of the design company we are doing that kind of design. Yeah, so I was talking about this product a little, like, I'll probably see, I'm telling you, within a couple of, like, this is like a future, I'm not say future, this is already here, but saying within few years, there are probably all the glasses now actually can have wireless power. Not only that, now the glasses actually, have some kind of camera, and probably in future you don't need to use a phone. Maybe you can use a glass. So there is a AR VR headset there, but now they are going to the much more smarter glasses, or maybe you can have like a training glasses, like, so ultra train, or maybe you can have a glass that you can join your Zoom meeting. So so that's the future one. Glass is a very interesting problem in the sense that There is not a lot of space to design your antenna. So one of the obviously place you can design is your glass itself, like, but then you have to be transparent and all those things, or you can have your design probably in a temple. So the last one we design it for that temple, and obviously temple doesn't have a lot of space. That's the challenge. Also, you can place your glass like either way, so that's the challenge. Um, but I'm telling you, like probably he, it will come to the India market or maybe already there. So that's the very exciting thing. I know we cannot avoid that kind of future. Anyway, so this is the kind of medical implant I want to talk about, because if you're familiar with the Neuralink or the other thing, other company, probably Patient Neuro. So these companies are now having some kind of neurostimulator in your head. So and so the idea is, if you have Alzheimer, or if you have, because of accident, you are paralyzed, your brain is not functioning, then they are stimulated your brain with a signal. That is one of the cases. You can use that. Or you can have your, like you have a heart attack or something and your heart is not functioning, then you can have like a pacemaker inside your body, right? Also, there are maybe now you have like some insulation pump. But insulin pump may be outside, but I'm saying that if you have probably very realistic case is like you have like a pacemaker, and then you have your like cochlear implant. So, and then you have some kind of neurostimulator sensor. These are very realistic. Actually, we already work with the company with this product. So, so they're already, some of them are existing. It's of course pretty costly. It's probably not for everybody, but I'm saying that they're already existing there. So obviously one of the problem with that for like a pacemaker, like, and then after 5 years you have to go another open heart surgery. You have to just to change the battery, so it's very costly. So and then one of the other problem is if you want like a larger battery, so and then if a OS and connector, that's not possible. So one of the thing is you can use wireless charging to charge your implant. Again, this is a very complicated topic in the sense that, because if it's an implant, it's a biocompatible. You cannot use you have to use the biocompatible material. You cannot use any shielding material or ferrite. You cannot use copper. You have to use silver or gold for that. So there are a lot of restrictions that there. Also, that then your charging have to touch your body. So, and then you have FCC limitation how much power you can transfer. But I'm giving you some excitement that okay, so that probably, of course, less than 5 to 10 years, you'll probably see a lot of medical devices coming with wireless charging system. I mean, which is, I think, that very necessary and the right thing to have. Okay, so here is again. Now I want to talk about the AI, so artificial intelligence, how the artificial intelligence is changing the wireless power transfer. These are real. I'm saying so that these are real. Already the companies are working on that. That the AI-driven solution probably for consumer electronics is like a smart alignment. Probably when you're charging, that probably the pad moves itself, like so that can be very possible. Probably for a car, it's very realistic. There's IoT and sensor network, electric vehicle. This is very possible. And aerospace and train always is that your laser or RF beamforming is changing with the data, train data. So this is the last slide, and I'm just to tell you how we are using the AI in the new current. and then how the other companies are using the AI in the new in their space. Of course, which city use the EV wireless charging solution, exploring AI for alignment optimization. So the RF technology they are using the beamforming for safe and targeted wireless power. So basically, the idea is if somebody is walking beside the array antenna, so and then it's tracking the walking, and then changing the beam according to that. However, we are using the AI, so we're using the AI a different way. So we are using the new kind of AI for faster innovation and reducing the workload. So instead of so we build our own custom solver so that we can have the AI driven workflow. So right now we are having the code is kind of designing the geometry. So basically, okay, if somebody wants a solution for a phone, so that our system can read that outline, understand the requirement, and try to generate the geometry based on that, and then there is a machine learning regression model to train that. Also, as we had using our own solver, is much faster. So that if previously, if there's a 60-minute necessary for modeling and modeling the coil or antenna, now AI can do that part. So and then it can try different layout and layer and different conditions, So also, right now we're using that for saying tuning. So you don't need to manually tune, or you can have your tuning tool to tune that system. So the AI can optimize your circuit and give you a few results for that. So that's why all the places AI is try to take the decision and replace for the heavy simulation runs. Yeah, so this is the type of thing I want to give. Yeah, so this is my last slide. So yeah, that's all from me today. Thank you for listening.
Okay,
And
sir.
I'm sorry for my camera is not working. So
Okay, sir. Sir, actually, the slide is was still it is showing. So the participants wants to see the slides one by one. Actually, there is only 2 or 3 slides they have seen. So can you scroll it once again? It is our request, sir.
Okay. I shared the slide right with you, right?
Yes, sir. Yes, sir. Please show all the slides. There are a few questions also there, question answer session. After showing the slide, we'll start the session.
Okay, can you please repeat which slide they want to see more? So is there
Actually, there is only 2 slides I have seen also. So they want to see every slide actually. No slide is, we can't see any slides, one only except 2. So can
really?
you? Yes, yes, sir.
Okay.
So can you scroll it from the starting?
Okay. I mean, you can share the slide to the participant, right?
Yes, yes, yes.
I'm not sure why, because it shows me I'm sharing the slide. Is it not?
No. There is only one slide was still there. It is,
Can
I
you
think,
see it now?
now I am seeing the fifth slide. It is
Okay.
before that there is only a still slide is there.
Oh, really? You could tell me. I was saying, I could try. I was saying, I don't know. So it
Now
is
it is
because
this one is always still is there. Sir, please so the next slide, sir. Number 9. Um, please go on, sir, on the next slides, one by one, little bit slowly, so that everyone can watch that slides.
okay, I can go real quick, maybe,
Okay, sir. Little quickly, you can go on.
So this is okay. This slide is I'm talking about that what the far field companies right now working on. And this slide is basically the far field wireless power transfer uh, uh, principle. So on the left side, how the RF or microwave transfer is happening. On the right, how the how the laser is working.
Okay, sir.
And then this is the one I'm very sorry about that. I did not realize. And yeah, I saw that you sent me a message, but I forget that. So this is the kind of far field wireless power transfer built by the OSIA. So that you have a tower, and then you have your uh, far field device that. Okay. Let me quick check one thing. Let me see why my camera doesn't.
Sir, can you see the other slides also?
Okay, yeah. So these are this is the one I was talking about. That okay, this is the how I talk about our different products right now in the market. So no slides.
It is showing, sir. The slide is showing 13 number slide. It is showing.
So this is the product we would do. This is the smart glass product we worked on. Then there is a fitness like a treadmill, and then this is This is the headset, a bunch of earbud. So then we call it pop socket. So this is the pop socket transmitter. And then I talked about the fitness band hoop. So this is a hoop design model. And then this is the concoction sensor, like for the prevent biometrics. And this is the this is the Spalding the basketball. So
Sir, please go on the other slides also.
yeah.
So
Yeah, this one is much more. I talked about the IP, so that so so I talked about the IP, how we normally do that design, and so the idea is for a product we try to design, create a wireless charging tower, but that from the transmitter coil is in the middle, but there are other antenna which are passive antenna on the side, and they can coupled to the field is coupled to the side antenna and then bend, and the field is connected coupled to the phone uh, um, and the watch. So this is much more like, the idea of how the smart glass wireless charging. So it can be a carrying case or it can be a charging pad. So um, I'm talking about what is the challenge for that. So because you don't see the receiver coil or the receiver antenna, so that's actually hidden in your temple. So that's actually hidden in your temple. So you can use some other technology like conductive layer or conductive uh, uh, glass, but these are some of the challenges. Then I talked about much more on the medical implant, and so these are some of the right now the implant that can be wirelessly charged. So there is one for like cochlear implant. So there is also a neurostimulator. As I said, like there are companies like Elon Musk company like Neuralink, or they are working on that. So one of the thing is they actually have a surgery and you have the implant inside of your body. So, but normal cases like a pacemaker for few years, you have to go through like an open heart surgery, right, to just for replacing the battery. So instead of doing that, you can have your wireless charging system, which can charge your battery from the outside. So, and also there are like other possibilities though, but probably, you'll probably see more things are coming with this kind of thing. And this is a kind of a slide where actually how AI is breakthrough, like different wireless power technologies. So how that's kind of fostering the innovation and using it to make it more smarter. So obviously for the aerospace and drone, like there's a real-time beam trafficking you can actually do. So and then electric vehicle, actually it can do the smart coil alignment. So obviously the goal is to reduce the power loss. And medical implant, and they are doing the same thing.
Can
And
I see,
then
sir?
yeah, so then I'm talking about our AI journey. So our AI actually we used to automatically like creating the coil geometry, and then also the creating the regression model and train the model. So for the very similar cases, actually the new kind AI can actually create the geometry. Also, there is a circuit element with it, so it can do the amplifier tuning and design and circuit simulation simultaneously with the design of the coil. So that like for an engineer, like saying it takes like also it's faster the simulation, so it actually reduce a lot of load for engineer. So maybe 60 minutes to 1, so something like that. So and then obviously you can actually drive the surrogate models right in the neural network. So there are a bunch of network for that. So that's what we are doing. But there are Utracity and then OCI, they are doing using the AI for different things. So
Okay, sir. Thank you, sir, for your informative session. Actually, we have a few questions from our participants. Professor Sumon Haldar. Professor Haldar, can you listen to me? And you can ask your question now.
Yeah, I'm listening you.
Please go on with your question.
Sir, is it possible to design a wireless power transfer or wireless charger for EV battery pack, typically current rating near about 25 to 15 ampere range for 45 kilowatt hour battery pack?
this is a good question. I'm saying the problem is not you cannot design anything. So the problem is, do you have really the component with that rating? So do you have really have the meet the temperature requirement? So in our lab, we are not doing the saying for EV range. So the maximum we did for 200 watt of power for like power tool, like saying, okay, if you have a handrail or like if it's, so we did that. So one of the challenges I'm saying that theoretically you can do the math. So it's like saying if you have 45, you say 45 kilowatt, right? Say, okay, and then probably 96% efficient system, right? But if in a 96% system, probably you have probably 2 kilowatt of losses, like, and then how actually you can distribute the losses over your system. That's the most challenging thing, that's a way I'm seeing. So, and then do you have that rated component or not? And, do you have that uh, uh, system to do that now? So, uh, that's what I'm saying. Yeah. But again, my company is working, or I have been experienced with less than 200 watt, but I know some company is working like, more than that. So like some obviously kilowatt megawatt ranges. So I don't know, is it answer your question or not? So yeah, it depends, like, so yeah. So theoretically nothing, nothing blocking you, right? Saying, you can plug in the math and then you can see that it's theoretically happening. But now your question is, do you have the component for that? Or like this component is that rated, or how much your board temperature goes up? Like saying some of our project for I'm like doing for a 1 watt of power, we can transfer power, but the problem is it we are blocked by the requirement of temperature rise or a specific absorption rate, like the FCC rule actually have how much rated power you can do. So
Okay, sir. Okay, sir. I understand the limitations. Okay, thank you so much, sir.
Okay. Is there anybody to ask any questions to sir? Please feel free to ask him. Please go on. Any one of our participant had raised his hand. Ankit Bhattacharya, please go on
Hey,
with your question.
hey, yeah, hi Nach, can you hear? Hello.
Yes, yes, please go on.
Okay. Uh, so I have two things to ask, Nach. So as you are working for last many years in this wireless power transfer domain, so I want to know first that what are the major challenge that is going to come in next 2-3 years? The major challenges in terms of wireless power transfer device design. That is my first question.
yeah, okay. What is the second question?
Yeah, and second thing that I want to ask you that as you are discussing about that phased array kind of concept, right, for the long distance, I think power transfer, that
Yeah.
was really interesting. So, is it already developed in market, or it is still in R&D state? So that I want to know, and because
Okay.
and what. Yeah, what kind of concept is it? Like phased array antenna, the same way it is working? You can change the beam like that, or what? Just a brief idea. I want to know that. Yeah.
Yes. So okay, thanks for the both questions. So first question, what is the challenges? So I would say there's two challenges. I'd say not two, but obviously one of the challenges is we want more power, right? We want faster charging. We want quicker charging. So, and that we like, the just now the other person, like, he was asking, can we do like 45 kilowatt of power? So that's kind of the challenge we try to address. So that can we pump more power without having the restriction? So that may do that we can try to having a, one of the restriction right now is coming from the losses. So the losses in the coil, the losses in the technology. So, and then you actually can reduce the loss. Then you'll then don't have any thermal limit then, right? So then there is some new material or new technology. I see that the companies are doing in different ways so that they can pump more power. That's kind of one challenge there. There is a major challenge in the wireless power transfer, as you can say that is charging multiple devices always a challenge, right? Because if you want to charge a multiple device, then you have a larger charging pad. Then you have a charging pad, then you don't want the other part to be charged. So that's always there. So there are standards. They're doing that kind of challenge on that. So, and third one, I would say then there are other devices, and that obviously distance is a challenge. So all the devices you need larger distance. Yeah, that's what I'm trying to say. The second question about the phased array thing. So there's a company they call OSIA. I mentioned in my slide. Maybe I can show you over here. They already have a product. So they already have a product. They have they call it Kata, like So they actually inside that they are transmitting power with a phased array antenna, and I think they sent us a sample, and I have the picture for that. I remember it has like 3 or 5 antennas. I think it has 3 antennas. And they are operating at 900 megahertz. So that's kind of that. They have a few other products. I heard that they are working with the Walmart or some other store where they want to have like a little bit digital display tagging like the price and the product name, so that the goal is they want to control multiple device from the rooftop, like you have like a array and you can connect to all those things. Not only through the communication, also you want to charge one by one with your beamforming, like that's mentioned in their website, but I know they have a product. I don't know how far it is, and the last time I saw that was like they can charge up to like a meter, but when I tested that, their efficiency is like a very poor, like say 1%. So basically what happened is it can transfer 100 milliwatt of power, but their input was like 10 watts. So they do it probably less than 100 milliwatt. So if there's application less than 100 milliwatt, you can use this thing, because as I said, one of the problem with that is that there's a restriction coming from the FCC, or IEEE, because that kind of power is helpful for the human body. So that kind of radiation close to the human body. So does that answer your question? So hopefully.
Yeah. Thanks. Yeah, thanks.
Sir, I have a question. When I'm using these gadgets, you are using wireless power transfer method. What is the drawbacks of using like body, any gadgets using in a body? And
This is
you
a
are
good question. Yeah. So, okay, this is a very good question. I think this one is started like, I think last 30, 50 years. So, and the lab I was graduating, the University of South Carolina, they are doing the research on that. So here is 2 things that I have to say, it's not only wireless charging, it's also your phone when the phone is transmitting. or maybe when you are watching something on your lap, so that it's getting hit. So that there is a concept that okay, there's a 900 megahertz that's kind of connecting and going, and then so uh, the answer to the question is the power is not that it can change the molecule, right? Basically, I'm saying that it's not nothing radioactive, like it change the molecule, but that's not the problem. I think the problem is it generating the heat. So the heat, some of them are radiated heat, like saying, okay, you have 900 megahertz, and if you put it close to your chest and something like it can heat up your chest muscle. But other thing is, which is pretty real, I think that if you're watching a video or something, right, it generating a lot of process power, like processor you're using, and then it creates a lot of heat. That heat might create a problem, but it's not 100% proven. So, but normally, again, the problem is that whole heat generation problem is like need to be studied for 30 years, like saying, okay, if I hit a part of your body like 20-30 years, how that have an effect. So, but there is a real concern. You put the for man is to put that phone inside your pocket or something, and but and then probably close to your chest. I feel that some of things are real in the sense that uh, that if you heat up your tissue, like then actually it's not good for the body. But technically, it's not 100% proven, and I'd say not proven in the sense that there is a radiation can change or modify somebody, right? That's not proven. Yeah. So, but I'd say that there's also a chance that the temperature change uh, can have create a long-term generation, like cancerous tissue. I'm saying maybe you have something and then you have heat up your body that can change over the time. So um, um, so I'd say try to be careful, and also I'm not putting my phone underneath my pillow anyway. So, because okay, why am I not doing that? Because if you don't put your pillows underneath your phone underneath your pillow, because then phone, if I put under your pillow, phone is now transmit more power to connect to the your BTS, like the tower, right? And then obviously then some of the things actually probably going through your brain, and at least it created disturbance in your sleep, right? So if nothing else. So
Oh, okay. Thank you, sir. Anybody has any questions anymore to ask, sir, about wireless power transfer? Okay. I think nobody has any questions more. So,
yeah, I have to say one thing. I mean, my what do you call it? Team works perfectly with the camera. I don't know why it's still not allowing. It's probably Google Chrome is not allowing. I guess something like that. I'm really apologize for that.
no, sir,
Because
it's
maybe I should
okay,
tell
sir.
this thing.
It happens. It
I
is
should
your
tell this
first time.
thing.
So, so it's okay, sir. No problem, sir. So thank you, sir, and for your informative session. And another one thing, uh, we have uh, we have a we want to share you a memento for you from on behalf of your college, Dr. Sudhir Chandrasur Engineering and Technology Sports Complex. And this is please accept it, sir, and we'll send it the PDF copy of this to your email ID.
Okay.
This is a small memento from our college, sir.
Okay. Thank you so much. Again, I want to thank the organizer. And I want to thank the program chair and the chief guest, and and the college, and obviously Dr. Pradipto actually took a lot of burden. So I say I want to thank him again. So thank you so much.
Okay. Thank you, sir. Thank you very much, sir.
Okay, thanks. Bye.
Okay, sir. Okay, that's all for tonight. The ATAL FDP program, the session 4 has been ended. Please fill up the Google form for feedback, and we'll start the session for the in the next day with our more two speakers. There are two speakers are from. I am telling you about the. There are speakers from. One is Dr. Banot Robi. He will discuss about the next generation vehicular communication. His session will be from 6 p.m. to 7:30 p.m. And another one is Mr. Ranojoy Ghosh. He's Dr. Robi is from assistant professor of IIIT Trichy, and Dr. Ranojoy Ghosh has a session of session 6, 7:30 p.m. to 9 p.m. He'll discuss about the AI in modern communication system. So he is from program and project management from LTI's Mindtree. So thank you everyone for listening patiently, and please fill up the Google form. Okay, we are giving the feedback link. Please wait for some time.